Now we will discuss the second part of this topic, which is horizontal distribution of salinity. Horizontal distribution of salinity, as it will vary from place to place in the oceans, so we have categorized it into three different parts. First is salinity of open ocean, salinity of partially closed sea, or salinity of enclosed sea, or I can say lake. All the three places, salinity will vary from place to place. As we have already discussed the factors affecting the salinity, with same factors we will apply in the three places and see how salinity will fluctuate from place to place. If I first take a case of open oceans, as we go latitudinally from equator or horizontally, open ocean can be at equator, open ocean can be at tropics, and open ocean can be at poles. If I take an example of Atlantic, salinity of open ocean, if I take example Atlantic at equator, salinity of Atlantic at tropics, and salinity of Atlantic at poles. Salinity of open ocean in tropics, especially in the areas of Tropic of Cancer and Tropic of Capricorn. Salinity is very high. The reasons being, first, evaporation is very active, which is because of clear sky, temperature is high, and steady trade winds. In tropical areas, trade winds flow regularly. Thus, as you know, factors affecting evaporation, more the wind movement, more will be the evaporation. Because if wind movement is more, the saturated mass of air can be replaced with the unsaturated layer. Thus, as it becomes unsaturated, it can hold more water vapor. Thus, as it can hold more water vapor, there will be more evaporation. Another factor for high salinity is rivers are very few. Thus, addition of fresh water is less. As the addition of fresh water is less, salinity will become high. In this area, the salinity will be approximately 37 ppt, which is 37 parts per thousand. So these are some of the factors which increases the salinity in the open ocean, in tropics. Now, we will move towards the equator. Salinity at equator is less. The reasons being high humidity, influx of big rivers which bring large quantity of fresh water. If I take an example, around this equator you have river Amazon in South America. This river Amazon starts from the Andes mountain in Peru, flows through the Brazil, and then outflows into the Gulf of Macapa in Atlantic. As it is the largest river of the world, it brings large quantity of fresh water, so salinity will decrease. Another example is river Zaire or river Congo. It also flows along equatorial region and outflows into Atlantic Ocean. It also brings large amount of fresh water, thus salinity will decrease. It is the only river in the world which touches equator twice, or which crosses equator twice. Rainfall is high at equator, due to which salinity will be less. So salinity is less there because of high humidity, influx of big rivers, rainfall is high. These are some of the factors which decrease the salinity at equator. The salinity at equator is 35 ppt. Now if we come towards this salinity at poles, salinity in poles is very less. The reason being, evaporation is less because insolation is less. Second factor, due to melting of glaciers and ice caps, they will yield fresh water. Thus, this snow melt will yield the fresh water and salinity will decrease. The salinity here is 22 to 32 ppt. If I go with this, 22 to 32 ppt. This is the salinity variation in open oceans at tropics, equator and poles. Thus can I say, tropics onwards when we move to equator and poles, salinity both decreases. Now we will discuss the salinity in the partially closed sea. There will be a variation in the salinity in the partially closed sea, which will be clear with the following examples. If we take an example, first salinity in partially closed sea, tropics. Salinity in partially closed sea at poles, because around equator we have very less partially closed bodies. Now when I say salinity in partially closed sea at tropics, if I give first example, Red Sea, Persian Gulf and Mediterranean Sea. In these regions, salinity is approximately 37 to 41 ppt. Reason being, as they are partially enclosed, influx of river is less. Thus, addition of fresh water is less. And second, evaporation is very active there, being tropical area, and because of the effect of the adjacent landmass. Thus, in this area in tropics around Red Sea, Persian Gulf and Mediterranean, which are the partially enclosed water bodies, salinity is this much. If you see the previous case, at tropics, salinity was 37, but in partially enclosed it is slightly more. However, if we take an example of Black Sea, which is also partially enclosed, salinity here is approximately 18 ppt. It is because rivers like Danube, Don, Dniester and Dnieper They carry large amount of fresh water which come from the snow covered regions of the Europe and drain into this Black Sea. Thus, in comparison to Red Sea, Persian Gulf and Mediterranean, here salinity is less. Now, if we take an example of poles, salinity in Baltic Sea, it is less. It is around 11 ppt near Sweden coast, and it is around 2 ppt near Gulf of Bothnia. The reason being here is, first, evaporation is less and the snow melt from Scandinavian mountains bring large quantity of fresh water here. There are a lot of streams coming from Scandinavian mountains because these mountains are covered with snow. When this snow melts, lot of water streams, they drain into this Baltic Sea, thus salinity decreases. This is the variation of salinity in tropics, where we have Red Sea, Persian Gulf, Mediterranean Sea, where we have Black Sea. Now, as we move towards the poles, where we have this part. Now, third case is salinity of enclosed sea or lake. Enclosed sea and lake, in tropics to subtropical belt, we have Lake Van in Turkey, Dead Sea between the border of Israel and Jordan, and Great Salt Lake in USA. All the three lakes, they are landlocked. Thus, salinity in these lakes is very high. Lake Van has approximately salinity of 330 ppt. Dead Sea has salinity approximately 240 ppt. And salinity of Great Salt Lake, it is approximately 220 ppt. This reason for the high salinity is evaporation is very active in this zone, is high, and influx of river is very less. Thus, high evaporation make these lakes progressively more and more saline. Rivers are though flowing, but they are very less in number. If I take an example of Dead Sea, the only river which outflows into the Dead Sea is River Jordan. So, as the influx of rivers is less, salinity here remains very high, and this evaporation progressively make this area more saline. Whereas, if we take an example of Caspian Sea, it is again landlocked, but salinity here is 14 to 17 ppt. The reason being, some rivers which are coming from the mountains like river Ural and river Volga, these rivers come from the snowmelt region, thus brings large quantity of fresh water. Thus salinity will be less here. These are some of the factors along with the distribution of the salinity in the oceans. Salinity is never fixed, it varies from place to place depending on the conditions, where we are talking about the open sea, partially closed and completely closed.